Newton, do you want to start us off?
I'm supposed to start.
Do you just want to introduce the group like we do
Okay.
in the video recordings?
Yeah. So, hi everyone. This is another meeting of the Ruby Junior Book Club, and today we are still covering Ruby under microscope. It's me, Newton, and Nelson, and Miles. And today, Nelson will be taking us through. I think it's
Yeah, it's chapter 6.
chapter.
Okay. Okay, so the chapter is method lookup and constant lookup. So this chapter is going to talk about how Ruby finds the right method because we have this inheritance hierarchy. And because we have this inheritance hierarchy, we could have inherited a method or a constant from a superclass or an included class. Uh, so how exactly does Ruby go through this? Okay, so we'll see. So the first thing that we're going to talk about, or this chapter talks about, is how Ruby implements modules. And we have to try to understand how Ruby implements modules because it's very important to how it looks up where your method is defined. So the key differences to the module system between classes and modules are that, so for classes, you can instantiate a new class. You can specify, like manually specify what subclass, the superclass, um, and you can, and it means that it's only inheriting from a single superclass. Um, And so there's a single point where you can say, okay, this is the superclass of this class. For modules, it works a little differently. So you cannot create a new instance of a module. You cannot manually define a module as a superclass of anything. We'll see later on in this chapter that it does happen, but it happens under the hood, and the programmer cannot specifically define the superclass for a given module. Um, and then a module can be included in many classes. And because it can be included in many classes, this is a way to skirt around. Um, in other programming languages, you might have this idea of multiple inheritance, where you inherit behavior from multiple different classes. But instead of doing that, we because that causes some issues, we use modules to define behavior, and we can include many modules in a class, and we can include that module into many classes. And so that behavior can be uh, dis distributed among lots of classes, and that class can sort of uh, implement that multiple inheritance without actually having that in the language, because you still have a single chain of inheritance. Okay, so how are modules represented internally? So modules are represented internally as classes. So we have the keyword module that's defining this professor module. And internally, Ruby represents it as a class. Inside that class, we have an RBasic object or a pointer to an RBasic object. Um, and we have a method table for that. And then we have this other thing, RB class ext struct, which has defined in it the superclass pointer so that we know what the superclass of this class is. Class level instance variables, the constants table, and the origin or what it's used by. I was a little confused by this origin thing. So it when it gets included in a class, is that set as the origin?
So I was confused by that too. Later in the chapter, it seemed like it was just kind of a hacky thing around how prepend was implemented, or at least that was the impression I got. And I wonder if the
Oh,
current version of Ruby no longer works this way, because there were some limitations, and we could chat about that when we actually get there. Um, but I think it was using Origin to figure out to like kind of structure things so the class could be before and after, in a way, the prepended module. That was at least the impression I got. There was something I was curious about here, which was how does Ruby know this is a module? And I was wondering if maybe it's in that R basic flags, but I really don't know. There must be something here that tells the runtime that we're dealing with a module, but I don't know what it is. Um,
I mean, does it have to know? Because
I I think
it's
it does, because like what if I were to try to include a class? I think I'd get an error. So I think Ruby has to know if it's a module or not somehow, because they have different behavior. Like if I try to do .new on a module, I would get an error, which maybe could be implemented in a roundabout way, but I don't know how you would get around include and extend. Like include and extend of a class, as far as I'm aware. I guess I should try that. I assume you would get an error if you tried to include a class. I
well,
don't.
the so I think those methods get inherited from object, and this class doesn't inherit from object, so it doesn't get those new methods.
That could be the explanation for, well, everything all always inherits from object eventually.
Not modules.
I don't believe that. I'm pretty well, I guess I could try it out. I'll try it out I think everything ultimately inherits from module. So if I do like module M, let's see. I do m.class, it's module.class is classed. Oh, you know what? You might be right. Because if I do module.class, I get class, and then if I do .class on that, I get class again. So that kind of surprises me. So a module is an object, but maybe it doesn't have object in its ancestors. Anyway,
Right.
yeah,
Yeah.
that surprises me.
So it's represented as an R class, and the superclass is never going to be the object,
Okay.
R object.
Huh, that surprises me. Okay.
Um, yeah, I mean, I don't know where I learned that. I must have read it from the book somewhere at some point, but
Well,
it
here is a weird thing though. If I do c dot is a object, I get true. If I do a class or a module and do dot is a object, I get true.
so it's an instance object, but it doesn't inherit from the class.
Well, yeah, yeah, I get confused. I guess I'm confused by that. So, and maybe I'll have to do some research or whatever. But it's weird because a class is an object, a module is an object, but if I go through the class hierarchy, I don't seem to hit object. So I'm just confused.
Yeah, I mean
Oh
it
wait,
is.
see, so, hold on. I'm sorry. if I do c.superclass, I get object. But if I do module doesn't have a superclass method. Although like you mentioned, it's internal. There is an internal concept of it, but I can't access it externally. Anyway, sorry to like go on a detour there. I'm confused and I'll try to figure out what the deal is. But it looks like class inherits from object, but module, as far as I can tell, doesn't in a properish sense from the outside.
Yeah, I mean, if you, I don't know how you did your test, but if you included it in a different class, then it gets shimmed into the object hierarchy, and you will have an object at the end of that hierarchy.
Yeah.
But module by itself doesn't have the method new in it. So you can't just do module.new.
Yeah. For module.new, I think that could be explained in that way, but I don't know how you would explain if I do include class, I would get an error and I would need to know. I don't know how the runtime would know how to give that error if it doesn't know if the thing I'm including is a modular class.
Let's continue and
Sure.
come back to that.
Yeah,
that
and I'll
idea.
test that out too to make sure I can't include a class, but I'm assuming I cannot include a class.
Okay, so here's in this section we're talking about how we're using how we're using a module here. So we have a class mathematician, and we're going to include this module called professor. And when you include the module called professor, it basically creates a copy of this professor module. So we have the original professor module here. We create a copy of it, and we're creating a copy of it because we're going to have some variables that need to change. So the variables that need to change are the superclass of this new module, or this copied module. So we have the original, sorry, we have the original professor module, and then we have the copy of the professor module, and we're going to modify the superclass that it points to, and the mathematician here is going to modify its variables. So the superclass that this one points to now is person. And we needed to make a copy of it because we're modifying these variables, and it needs to be different every time you include it in whatever class that you're using. Okay, and that's not something that the book really stressed. Like the only place where you really see it is like here, where it says copy, and it does say that it copies it, but it doesn't say why. But the reason why is because we need to change the internal variables of it, so that we can shove it into the inheritance hierarchy.
Yeah, I was surprised by that too. I started wondering why it was a copy, and then later as I was reading it, that same hypothesis crossed my mind, and I was kind of surprised that he didn't just give a quick explanation of that. But I think you're probably right that must be the reason.
How about if we think about it in this way? Like, if you include a module, now let's say like professor, you include it in a class, yeah? If you don't get that copy, I assume if you make changes to professor, those changes are going to affect every place throughout the code where the same module is included.
Right. Yeah.
I don't know if that makes sense.
It does, yeah. I think the super pointer in particular is the thing we don't want to break, because that needs to be different for like Nelson was saying, every time you include this module, you're going to get a different super pointer to honor the hierarchy of that class. And so that's why I think we need and there might be other variables too. I actually don't know, but for certain, I think the super was part of it.
Yeah.
Yeah, I mean, and then when we see the constant pointers, the constants for these classes, well, I don't know, because this is a module. But when it does the constant lookup, it'll go through the inheritance hierarchy to every class in the inheritance hierarchy to try to find the constant that we're looking for.
Yeah, one
But
thing to
I
point out. Oh, sorry. Go ahead.
but it seemed like for modules it was different, that it didn't use the modules for that constant lookup. So maybe it does, maybe it doesn't matter for those included constants.
So at first I was kind of confused by that, and then I'm pretty sure what this diagram is showing is that dotted line is the inheritance before the include, and then the solid lines are the inheritance afterwards. I think that's what he's trying to show here, and I think that the constant lookups do actually pass through the modules if I remember correctly, but I think we'll come to that later.
Yeah.
But that was something I didn't understand the first time I was looking at this diagram. I think there's a chronological thing going on here where the dotted line is in the past and is no longer in the future. It was how I finally came to interpret this chart.
Yeah, so when the moment you include this module here, it erases the previous hierarchy chain, and it adds these new lines here. Yeah, that's how I read it as well.
Okay. Okay.
Okay, so Ruby's lookup algorithm. So it basically looks at the current class. It sets the current class as the receiver. It looks through the method table of that current class. And if it found the method, then it goes ahead and calls that method. If not, it sets the current class to the super class of the current and then repeats. Something that isn't mentioned here, but is mentioned in the previous book that we read, is that when it's looking for this method, it also looks for method missing. So if it fails to find the method in this using this set of instructions, then at the end of that, it'll go ahead and call method missing at the end of it and do whatever method missing says.
Yeah, I noticed that wasn't mentioned at the end of the chapter. Const missing is mentioned as part of the algorithm. So I don't know why it wasn't mentioned here, because it seems like if you're going to mention one, you would at least mention method missing, but I guess it just left it out for simplicity.
It's complicated enough.
Yeah.
Okay. So a method lookup example. We start with this class with these accessor methods, for the first name and the last name. Then we have this class person that we're going to inherit. So mathematician is going to inherit from the class person, and we're going to move these variables up into class person. Okay, fine. So now we have this structure where we have a class mathematician that is inheriting from a class person that has these accessors for first name and last name. Okay, so now we're going to introduce this module into the mix. So we have, we're including the professor module into the mathematician class, and it's also inheriting from person. Great. Okay, so we can make a new mathematician. We can set its first name to Srinivasa. Okay, so Ruby needs to find the first name equals method. Where is this method and how exactly does Ruby find it? First, Ruby gets the class from so we have this Ramujan object, and we look for it in the mathematician class for the method table in the mathematician class. Next, Ruby checks to see whether mathematician implements first name. Okay, so it sees that mathematician is empty, and here we see that mathematician does not have that method inside of it. Okay, great. So because we've moved all the methods down into the person superclass, the first name equals method is no longer there. Ruby continues through the algorithm and gets the superclass of mathematician using the super pointer. And so we're just basically, we didn't find it in the mathematician class. We didn't find it in the professor. We didn't find first name in the professor module, so we went up to the person class. And that's where we found first name. Okay. Yeah, this is where it talked about multiple inheritance. So it's basically the same thing I said before. We're enforcing a single list of ancestors, but we get the benefit of being able to include multiple things with modules. Okay, so this is sort of this set of instructions for looking up the methods is sort of costly because first we're looking here, we're looking through the method table, we're iterating through the entire method table of mathematician, we're iterating through the entire method table of professors, we're iterating through the entire method table of person. So if we have a really, really long inheritance chain, this could get very, very expensive. So once we've found where the method is, we use this method cache to make sure that we don't pay that expensive operation very often. So we were looking for that times method so we called fixnum.times. It went up through the inheritance chain and it found it on integer.times. So here it's basically, it says this is the method I was looking for. This is where I found it, and now I have this table of where I can call the actual method. The only other wrinkle here is that when you do metaprogramming, you basically have to clear this entire table. And I mean, I don't know the Ruby internals that well. I was at first glance, I would have thought, oh, you only need to clear whatever method you're interested in. But this paragraph basically said, no, every time you do some sort of metaprogramming, you basically clear and regenerate the entire table.
Yeah, I wonder if it still works that way today. And I wonder if they also just kind of looked at usage patterns and for whatever reason decided that gave the better result. I don't know. Yeah, I was curious about that too.
In addition to this global method cache, we also have this compiled. So we also inline it into the YARV instructions. So whenever we know that where the method actually lives, and we saw above that the times method, the fixed num dot times method actually lives here in integer dot times, it gets compiled into the yarv instruction. So you don't even need to look at the table. You're just inline it into the yarv instruction, and the runtime just uses that.
Yeah, that kind of surprised me, and I wonder how it seems like the cache invalidation there would be kind of like the clearing the global cache would be really trivial, but I don't know. I wonder if it's complicated to clear all these tiny little compiled method caches or not. So that kind of surprised me a little bit.
Yeah, I'm not sure. Yeah, so I mean, this is where it says it clearing Ruby's method caches. In order for you, okay, so because Ruby is a dynamic language, you can define new methods when you like. In order for you to be able to do so, Ruby must clear the global and inline method caches because the results of the method lookups might change. Yeah, so it also has to clear those inline method caches.
Yeah, and that kind of surprised me. It surprised me when it mentioned that they're short-lived because it seems like when the program is first starting up, that would make sense. But it seems, at least the programs I usually work on, the meta programming all kind of runs pretty much up front. And then I don't really do any, like if the process is going to run for an hour, like all the meta programming happens in like the first 30 seconds or so, I assume. So you would think those caches would be good for a long time once everything settled down, but I don't know.
Yeah, well, I mean, so when you're doing like an active record find by method, so person dot find by name, that is using method missing to say, okay, we have this person model, and we have this name variable inside of person. So we're gonna do some dynamic programming to look up this thing. And I wonder if that breaks the cache.
I would suspect that it doesn't. I mean, I don't know for sure, but my guess would be that it doesn't break the need to invalidate the cache for that, but I don't know.
So maybe it only happens when you add or remove methods from a class then?
That's my guess, yeah. Which I do a lot of, but it all happens like in the first 30 seconds of the program, for me at least.
Well,
Yeah. Also, we don't know if this is true in Ruby 3. Like, who knows what their approach is now.
yeah. Okay, so moving on to the next section, and including two modules. So we'll look at this actually here. Wait, is this the right one? So we're including professor and employee. I see professor. Oh,
Yeah,
here's employee.
Yeah, this is actually where I figured out that the dotted line was in the past, because when you have these two diagrams, you see it's a two-step process. Yeah, now I remember.
Okay.
You know, he gets a little sloppy with what's a copy and what isn't in some of these, which also confused me a little bit, but then I figured it out.
Yeah. So so first we're going to include this professor because it's the first one in the that we see inside of the mathematician class. That's the first one that's gonna get included. And then we're just gonna update the references, the superclass references, so that the professor now is shoved in between mathematician and person. So that's the first step. And then the second step is basically now that we have this hierarchy where we have mathematician, professor, and person, now we have employee that we're also going to shove in there. And because it is, it's the last thing that appears here, it's going to be the most recent one that we put in there. And so the superclass of mathematician is always going to be the last include in the list. Okay, so basically we make a copy of it again, we shove it in between mathematician and professor, and we end up with a hierarchy that is mathematician, employee, professor, person. Okay. I didn't actually know you could include a module into another module. I've never done that. So this was new to me.
Yeah, I do this a lot actually. But yeah.
Okay. But basically it'll employee will end up being the superclass of professor here, this module. Okay, so modules can't have superclass in your code, so you can't manually define what the superclass is, but they do have superclasses internally in the way that they get represented with these R classes. So here we see that we have this chain that is mathematician, professor, employee, and then person. And that happened because we included employee into professor. Okay, so module.prepend. Okay, yeah, this confused me when I mean, it's still not clear to me. Well, I would probably avoid using it because it's still not 100% cemented in my head the way that works. But basically, we want to invert this order where we want to make sure that instead of having the expected order here that we did for when we included, it goes reversed. It becomes reversed so that you know here where we end up with something that's mathematician. Actually, no. Yeah, I probably should have opened IRB and just run this code instead of quickly reading through it because it's still a little mixed up in my head. But this is ultimately what's going to happen here. We're going to end up, if we want to prepend, or when we use the prepend instruction instead of include, what ends up happening is that we have this included professor class, and it is the superclass of mathematician, but because we want to preserve the original like inheritance hierarchy, where mathematician is still the superclass of professor, we make a copy of mathematician, we shove it in between professor and object, and now we have this hierarchy where it goes mathematician, professor, mathematician again, and then object.
Yeah, this shocked me because I always assumed that prepend worked by attacking the singleton class. And actually, he doesn't mention, now that I think about it, he doesn't mention the singleton class at all in this whole chapter. But in a different chapter, he mentions that you always get a singleton class, even if you're not going to use it. So he kind of ignores the singleton class in this chapter. But I always assumed that when you included a module, it worked off the class, and when you prepended a module, worked off the singleton class. Although in retrospect, I now realize that actually doesn't make sense. But then just seeing the way it actually works, like, really shocked me. I would never have guessed that it worked this way. With regards to prepend being confusing, it's kind of just like, if you want to override a method by including a module, like the reason you're including the module is to override a method, that's basically when you would want to use prepend. Otherwise, you would never use it. So it's like, it's pretty rare that you want to use it, but that's like the use case for it. Like, you want to override a method. You cannot override a method by including a module, but you can by prepending a module. Just to think of it from a use case point of view.
So why would you prepend instead of just updating the method?
Because if you were to, you might want to call super, for example, like, so you can't just, so like, if you include if you have the method in the module, but the class that has the method you're trying to override, when you call that method, it will find the method in the class first. It won't find the method in your module, which is not what you want, because you're trying to override the method in the class with the method in the module. And prepend lets you do that. So prepend is like one use case I can think of that I've had to use this for, it's the only use case I can think of, is if you want to override new. I've had to override new before, and I wound up, if you wanted to override it in a way that was like reusable, where you could reuse it across multiple classes or whatever, you'd want to put the override in a module and then mix it in to the various classes you wanted to override new in. But you can't include it, because then the method you're trying to override will get called first. So then you would prepend it. I don't know if that makes sense.
Okay.
But the only case where I've wound up wanting to do it is I want to override new, and I want to be able to do it in a reusable fashion. That's a use case where I've wound up using prepend that I'm aware of, but it's pretty rare. I don't know if that helps or not.
Yeah, it does help. It does help.
Yeah, so we have I think what less than 2 minutes, but I have a question about the prepend thing, which I think I'll air in the next meeting.
Okay.
Yeah, I think we should just join and then we start from where we've stopped.
Sounds good.
Okay.